Hello again and welcome back to another episode of Added Game Sounds, where today we're going to be doing two main things are on the agenda. Do some more tweaking like we did in the last lesson because there's still some things we can improve. We're also going to be adding some bubbly sounds to the crates. So these crates here, when they splash up and down in the water, we're going to give them some life and make them sound like they actually are splashing up and down in the water. Just a heads up for you all, today the 12th of April 2019 is the last day you'll be able to pick up a copy of the FMOD Unity Essentials course. I'll be taking it down at 10 PM Eastern Standard Time, so if you're still considering it, I'll have a link to it in the description of this video. And also don't forget, you can use the code SGS_bonus for 20% off. And for anyone who has already tried out the course, thank you so much for giving it a go, and I hope you're really enjoying it. Also, if you follow that link, you'll be able to check out the C# scripts page, and any of the scripts from this video you want to download or copy, you can. They're just all here. Okay, so we're going to kick this episode off with some tweaks, like I said. So we're going to first go into the FMOD player script, which we've looked at quite a lot. It's the script that's controlling all the sounds for the player. We're going to do some tweaking to the player falling function here. So recently when I was testing out the game, I noticed for some reason, very occasionally, if you jumped and the game kind of lagged, when Ellen landed, you'd still hear that falling whooshing sound that we added a couple of episodes ago. So we can't have that, can we? We need to basically check to see if that ever happens, and if it does, tell the whooshing sound to stop. We don't want that playing while Ellen's just standing around doing nothing. The way I fix that is with this line here. So as we know, this function is called every frame, the player falling function, and every frame we're calling this if statement as well. And we're basically checking all of these conditions here. We want to check to see if the player is not on the ground, if the player is falling faster than a velocity of -3, and if the player is not submerged underwater. If these conditions are met, then we essentially play our falling sound. Now, to stop our falling sound playing unnecessarily, we basically want to check to see when these are not met, and that is where the else if statement comes in. If these conditions are the opposite, so if the player is touching the ground, if the player is not falling faster than -3, or if the player is underwater, then we come down to this line here and we make these new checks. So in two brackets here, I'm checking to see if the player is touching the ground or if the player is submerged, as opposed to and if the player is submerged, like we were doing up here. We were using the double ampersand sign to check if any of these conditions, or sorry, to check if all of these conditions were happening at once. This time we just want to check if either of these are happening. They don't both have to be happening, just one or the other. Touching the ground or if the player's underwater. Once the else if statement's made that check and it comes back as true, we then want to check to see if the player falling sound is playing, which is what this playback state is for. Obviously we made that a while ago, and that's to check to see if the player needs to, or if the player's landed and we need to stop it. But this time we're checking to see if it's playing. So if the player is touching the ground or is underwater, and the falling sound is playing unnecessarily, we then come down to this line where the sound is told to stop and fade out. So it's pretty simple, and it's just a way to make sure that that little bug doesn't happen. Okay, so the next change is actually something I added in the last lesson, or one before the last lesson, and forgot to bring up. If we go to our acid game objects, or one of them, go to the water area script, we're going to take a look at the splash sounds that are made whenever something enters the trigger area that makes up the water in this game. So it's this part here we're going to look at, and we're inside the Ontriggerenter 2D function, which we've looked at a couple of times in this series. Now originally we had just one if statement, and if that if statement was true, we'd play a one shot of this event here, the acid splash sound. So it didn't really matter what entered the water, whether it was the player, a box, or an enemy, which can occasionally happen. I've seen it happen very rarely, but it does. It would play that event. Problem is, I actually noticed after we were messing around with the spitter enemy in the last episode, that occasionally some of the blobs that they sort of spit out, they can trigger the trigger area too. They can trigger this function. And when they do, that event is played. And it didn't really work for the kind of size that those little blobs were. So what I've done is I've made another event. This is called the Light Acid Splash event. And all it is just a one-shot, simple. It's acid pool splash 01. That's the audio file of it. If I play it for you now, sounds a lot lighter and a lot more suitable for those little blobs that get fired. So I thought we'd use this instead. So if we go back to our script, we're still checking to see if the scene has been playing for longer than half a second, because we don't want anything to play straight away. And if that is true, we come down to these two statements here. The first one is an if statement that just checks to see if the spit projectile object has entered the trigger area. We're checking it by name, but as you can see, we've added this extra bit here, the clone in brackets. That's because the spit projectiles are basically kind of cloned or copied from the prefab that is in the assets folder. And whenever it does that, they add this little clone sort of part to the name. So we need to make sure we're checking for that as well. The way we're checking for the name is the same way we check to see if Ellen has ever entered the water. We're just using the collision parameter, which is a variable of the Collider 2D reference type. So this is going to check to see if the object entering the water has a collider component. If it has, we can check information about that object. For example, we can check the name of it. Then if it's true, if a spit projectile has entered, we're using this one shot here just to play the light acid splash sound. We're also using the collision parameter variable again to find the game object, find its transform component, and work out its positional coordinates. And then from this, we can play the audio in 3D. Then if the if statement fails, and if it's not a spit projectile that's entered the trigger area, we then come down to this else statement here. And this will basically play the acid splash sound, the normal one, the one we've used before. So it's basically saying, check to see if it's one of those little blobby things that's entered the acid. If it's not, then we're going to assume it's anything else. It's Ellen, it's a box, or it's an enemy, which we can play the acid splash event for because it suits them. So this is a nice, easy change. It's actually optional. You don't really have to do this, but I thought it might be nice for anyone who maybe wants to mess around with the assets in this collection and wants to make their own levels. I might put a spitter next to the sort of acid pools. They might hear that happen a lot. So yeah, this changes there if you need it. Next little tweak is actually an FMOD thing. If we quickly go into our window, let's go to our mixer tab. Obviously, a while back we made this bus here, the sound effects bus, and this was for all of our sound effects. But where we've been making new sound effects since then, they've all sort of kind of piled up here, as you can see. So let's quickly grab some of them. Oh, whoops. Highlight them all, and let's just drag them into that bus. And there we go. They're all in. Good to go. Okay, so now it's time to move on with some stuff, some new additions. I was messing around with the game, and I noticed that, well, these boxes here that we can push into the water, Ellen pushes them over, as you can see, then they fall due to their physics into the acid here, but they kind of bobble a bit. And if you jump on them, they'll do a bit more bobbling. And I thought, well, that kind of needs a bit of its own sound. So what I've done, if I go back into FMOD, I think I put it in the interactables folder. Here we go. This is the event I created. It's called Bobbling Crate. And it's using the shoreline event that comes with the 2D game kit. And it's looped, as you can see. So let's quickly play it for you now. Oh, I almost forgot. Sorry, there's also a parameter attached to it. So it's this bobble parameter here. So basically, this parameter is going to check to see how much the crate is bobbling up and down in the acid. If it's bobbling a lot, it will be up to around about 1 or 80, which will automate the volume of the event so we can hear it. And if it's not bobbling at all, it will drop down to 0. So if I push it back up to 1, go to timeline and press play. We can hear some splashing around sounds. What else have I done? I've also added the spatializer event, and also it's 3D, obviously. I did have to do a bit of tweaking with the minimax distance of the distance attenuation, just to make it work. So feel free to experiment with that how you need to. I've also added some modulation to the volume of this event, just to fade it in and out. So when it's told to play and stop and stuff, it just kind of comes in nice and smoothly. And then other than that, it's a pretty simple event. So let's quickly jump into the game. I'm going to quickly play it for you and show you how it sounds without stumbling my words, hopefully. Right, so let's quickly jump up here. So here's our crate. Let's quickly push it into the water. There you go. So you should have heard the normal splash sound that we always get, but you should have also heard a little bit of an extra splishy splashy sound coming from the crate. Now, it's not moving, so we shouldn't hear any bobbling, and we can't, so that's good. But if I jump onto the crate, oh, whoops, like that. There we go, we hear a bit of bobbling, and then it kind of fades out. If I keep jumping, we hear some splashing around. Then if I jump off of it and kind of move away from it, let's get it bobbling again. It kind of fades out to the right because it's obviously 3D, remember? So yeah, this is just a little extra detail you can or you don't have to add, but it's optional and it kind of just gives the world a little bit more life, I suppose. So we need to know how we're going to implement it. Well, the way we do that is we're going to come over to one of the boxes in this game. We want to dig through the pushable script, which we've looked at a little bit before, so let's edit that. Okay, so here we are in the pushable script, and the first thing you can see is that I've added 2 new things. I've added an event instance called bubble sound, And I've also added a new playback state called PB state 2. We then scroll down and come to the awake function. You can see that the bobble sound event instance is now having an instance stored inside of it, and that is the event we had a look at earlier. So this one here, the bobbling crate. So now as soon as the game starts, we'll have an event instance of the bobble sound event ready to go to be played. Next, we want to scroll down to the fixed update function, which we know happens every frame, but it happens actually it happens 50 times a second consistently, as opposed to 60 times a second, but kind of fluctuates depending on how much is going on in the game and if any frame rates drop. So we're doing it in this function here. Now the first new line I've added is this one here. It's a command that uses the bobble sound. It's called Set3DAttributes. Now this is basically taking up the role of the command we have been using up until now. Let me find an example of it. In here, no, FMOD player maybe. I'm pretty sure the FMOD player has it somewhere, maybe at the top. Here we go, this one here. So attach instance to game object. So up until this point, we've been using this line here as a way of implementing our 3D events from FMOD into Unity. Using this line would allow Unity to basically collect data on the event's location, and then FMOD could play the sound accordingly. It could use panning and distance attenuation to make it sound 3D and like it's in a space. Now, originally, I was using this command for this game object. It's quite a nice command because you only have to call it once, and you're done, basically. The sound will be 3D for the rest of the game. Or rest of the scene, I believe. However, I don't know why, but for some reason, whenever I use this, you just couldn't hear the splash sound. I'm still trying to work out why, but not to worry, because there's actually another way we can implement 3D events from FMOD into Unity, and that is with this line here. So this is how you use it. You take your event instance, which in our case is bubble sound. You then write .set3DAttributes. You then create some brackets, and inside you write FMOD Unity .runtimeutils, which is a new class containing new commands we can use, .to3DAttributes. And then you need to give it, well actually there's a few different arguments you can give it, but in this case I'm only giving it 2 because those are the 2 we need. So the first argument needs transform reference data. So basically it needs to know, it needs to be referencing this component here, the transform one. The way we do that is simply write transform, nice and easy. So if this script is attached to the game object that you want to use as the position to play the sound at, you can just write that transform and it will take the transform component that this script is sharing a game object with, which as you can see they are, and it will just use its location to play the sound at. Then we're saying we need the rigid body component. So to get it, we're just writing get component and then rigid body 2D inside these little triangular brackets here, and that'll do the same thing. It will take the rigid body component, which is attached to this game object. As you can see, it's this one here, and using its physics information to work out if the object is ever moving, and then it's going to move the sound accordingly. Now, what's nice about using this as opposed to attach instance to game object, there's a few different options for the arguments you use. If that object didn't have a rigid body component, we could get rid of that and just do that, and it would still work. I believe you can also feed it a vector, so if you wanted to, you could write transform.position, and it would still work. Alternatively, you could store that vector3 or vector2 in this. No, it would still be vector3, I think. You could store that within a variable somewhere in your game and then feed that variable into here. And I think there's a few more options. I think another one is game object. So we could maybe even, if I get rid of that, we'd even just write game object. And this will take the location of the game object itself. That works too, but because our object has a rigid body, we need to definitely make sure we're checking for that. So let's get back our transform. Let's do some undoing, hold on. There we go, that's what we want it to work as. The downside to this, however, is that unlike attached instance to game object, it does have to be called every frame. So I guess, yeah, the downside is it's kind of, even though it's only a tiny bit if you're using it for one event, it's using a bit more work on your game side, a bit more processing power to find the location of where you want to play your sound. So there's pros and cons, ups and downs. You can use whichever one you want, but we're going with this one because it actually works in this time. Great, so we've got our event instance variable. We've got a reference of the event we want to use, which is this one here, the one we played earlier. We've also made it 3D, so it's a 3D event that will now play at the location of the game object in the acid bubbling around, right? Cool. So how do we get it to play? Well, we need to come down to this for loop here, which we looked at in part 8, I believe. So go check that episode out if you want to learn a bit more about for loops, but I'm just going to quickly sum up the purpose of this one here. So the idea was that every frame, if we quickly go back into Unity, this for loop was basically going to check for every acid pool in the scene. So in this case, it was 2. So it'd go, right, there's one here and there's one here. Then, using the if statement underneath, I believe, it was basically using the rigid body of all the cubes, or trying to locate the cubes and use their rigid bodies, and check to see if any of them had entered either of these 2 acid pools. Then if they had, we can go on to do, other stuff. So it's basically just a way of every frame checking multiple different objects and seeing if they've interacted, essentially. As you may remember from that part as well, we added these 2 lines here. So we added another if statement. What we were doing is basically checking to see if the falling sound, remember last time we added a sound that when one of these objects started falling through the sky, just like our player, it makes a rush of air start playing, a little whooshy sound. Basically, when the cube enters the water, we want to tell that to stop. So if one of the cubes has entered the acid, we basically want to check to see if it has stopped already, and if it hasn't, which is what this condition is saying here, we want to use the stop command to tell it to stop, and then we're also telling it to fade out using the stop mode here. Okay, nice and simple. Now, everything underneath that, this bit here, this is everything associated with our new bobbling event. So when the crate now enters the water, we're using the get playback state command to link our event instance that holds the event to our new playback state we created earlier, so PB state 2. Then we want to check to see if the event is playing using that playback state. So in an if statement, we write PB state 2. If it's not doing whatever's here, which as you can see I've wrote is playing, so if it's not playing, if that event isn't playing, we want to tell it to play. So we say bobble sound.start. So essentially, as soon as the crate enters the water, even if we're currently not hearing it because it's not bobbling, this event is playing, this timeline is going along, and it's looping and looping. Next thing we're doing is we want to basically collect the velocity of the object that's just landed in the water, and we want to store it in this variable here, which I've just called y. So if I scroll up a bit, you can see at the top in our class, I actually created a float variable, made it private, and I called it y. And like I said, this is going to store how fast the box is falling in the y-axis, so either if it's going up or down. Now, luckily for us, if we go back to the top of the fixed update function, there's actually a vector2 variable called velocity that is taking the rigid body that is attached to the object that's just landed in the water, so the cube, obviously. It's taking this rigid body and it's collecting velocity information from it, which is, I believe it's just... it's just another vector2 that's stored within inside the rigid body 2D component, which we know is this one here, okay? So taking velocity that it collects as the object is moving through the space. Then it stores that in this variable here, so the vector2 velocity. Now we know that vector2s, they hold 2 basically float variables, one for the x-axis and one for the y. And as you can see, we can basically follow up this variable with either .x or .y to access one of those float variables specifically as opposed to both of them. So that's what they've done here. You can see they've set x to 0. So now the box can't move in the x-axis. So what we're going to do, we're going to use the vector2 variable velocity here, but instead of using the x part, we're going to use the y part. So the float information associated with the y-axis of the object falling. So as you can see, that's what our y variable I created earlier was for. It's basically to store the velocity here in the y-axis. So as you can see, just like the programmers who created this script have done here by accessing the x part of that parameter, variable specifically, we're accessing the y part and we're storing it in a newly created y variable. Now, if you remember back to, I forget which part it was, but in one of our videos, we basically looked at Ellen as she fell through the sort of game, and her velocity worked the same way. It was using the rigid body. It could either be a minus number or a positive number. If it was a minus number, it basically meant that she was falling downwards. And if it was positive, it meant she was rising up or jumping. Now, because if we go back to our event, as you can see, it varies from 0 to 1. That's the range of it. And we're not really interested in any minus numbers. If it's moving up or down, that's when we want it to move up closer to 1. We don't want it to go -1. We're not interested. Well, if the box, let's go to Unity, I'm mumbling this up a bit. So if the box is in the acid, it's bobbling up and down, the velocity is basically changing from a minus number when it's moving down to a positive number when it's moving up. and again when it goes down, and again when it goes up. Now we're only interested in converting that value, whether it's a minus number or a positive number, into a positive number. It doesn't matter what the number is, so long as it's greater than 0, we know to play the bubbling sound. That's why if we go back into the script, as you can see, I'm using an if statement to check to see what the value of y is. And if it's greater than 0, I want to take it and I want to multiply it by -1. So that's what this line is doing here. It's basically whatever the value is, it's taking it and it's multiplying it by -1. So no matter what it was, it will now be a positive number. So let's say, for example, it was the cube was in the water and it bubbled up, and its velocity was, let's say, 0.5. So that meant the y value is greater than 0. So all of this is ignored, and we go from there. Let's say, however, the cube bubbled down and its velocity is now minus 0.5. Well, now we want to times it by -1, which will now make it 0.5 again, and we can now use that with our parameter. And then once we've done that little conversion, we're going to use that for our parameter. So as you can see, I've wrote bubble sound dot set parameter value, then I've accessed the parameter itself by name, which is bubble, and just turned that into a string. And I've told it to use the value of y to control, let's go back, oh, not that one, let's go back to it, whatever, value we want this to be. Now, in terms of getting this to work, I did have to do a lot of fiddling with the seek speed option. So those of you who use FMOD a bit, you might know that with seek speed, when the value of your parameter is changed, you can basically set a time that designates how long it takes for that change to happen. So what I've done is split it into two. I've made it asymmetric by turning this on. So if the value, let's go back to our script. Let's say the value is rising. So y is going from 0 to 1 to 2 to 3 to 4, whatever. Or sorry, it wouldn't be that. Let's say it's going from 0 to 0.2 to 0.4 and it's going up. If it's ascending, then we can change the parameter by a value of 2 per second. So that's basically what that means is it's going to move quite fast. So it's going to move quite fast and scroll up. However, if it starts to descend, if that value is going from say 0.6 to 0.4 to 0.2, it's slowly going to go back down. It's only going to change by half a value of whatever you measure these parameters in per second. So if I quickly play it for you, let's put it down to 0. Oh, you can already see it moving slow. So if let's say a value came in and it came out at 0.7. You can see by that little yellow dot, it's shot up quite quick. However, if it came in at, let's say it went down now, so it went 0.2, it would slowly go down. And the reason why the only reason I did that was basically just to get the kind of feel for the sound to fade out. And seek speed is quite important in this case because the value of y, the velocity, it's kind of flip-flopping all over the place. So if I go back into FMOD, if we didn't have any seek speed on at all, this is what it would look like. Instead of smoothly going up and smoothly going down, it would do this. It would sort of like jiggle and joggle up and down, and it wouldn't sound, the sound would be fading in and out quite quickly, and it would go down again. It wouldn't be very smooth. So that's why the seek speed here is quite important. Now, one other thing I should mention, for those of you using FMOD 2.0, the API has changed. This line will not work for you. So if you're using a version of, a version of FMOD beyond 2 or beyond, this won't work because this is now outdated. I'm using version 1.10.10, so it still works for me. But if you're using a new version, you're going to want to write this. So you'd write bubble sound dot set parameter, not value. You'd write by name. Then you'd use 2 brackets, and you'd first enter the name of your parameter, so bubble. You'd do the same thing. You'd enter, whoops, get rid of the quotation marks. You'd enter whatever variable is going to control the value of it, so it's y. But you'd also add a new argument. You want to basically say whether or not to ignore the seek speed option of that parameter. So you'd either write true if you want to ignore whatever values you, let me find it, assign here, or you'd write false if you want to not ignore them, if you want to use them. I guess the reason why they've added this is so that if you want, midway through your game, you can change whether or not you want to use seek speed or not. In our case, we definitely want to use it all the time, so we would write, we would write false. So we want to make sure we are not ignoring seek speed. Now, obviously, because I'm using an older version of FMOD's API, I've got an error. It doesn't recognize this command. But if you're using, like I said, 2.0 and above, this should work for you. Last thing we need to do is if we scroll down, we come to the onDestroy function, which we know is triggered when the game object, in this case, the box itself, is destroyed. And it will be destroyed when we change levels. So what we do if this happens is tell that event to stop playing, just the player's leaving the area anyway, so we might as well tell it to stop immediately, And then we also use the release command to destroy the event instance, so it's not just sitting there doing nothing. And I think that is everything. So there we go, we're all done. So that's how you can add a little bobble event to your boxes, your crates in this game. Again, just to give a bit of life to this game. It felt a bit odd that these boxes were splashing up and down and not making any sounds. It's not really. I don't think that's what the event. If we go back to FMOD, I don't think that's what this audio file here was designed for when they created all these assets. But it's not what we're using it for. So yeah, it's a little detail you can or can't add. It's up to you. But yeah, that's everything. Thanks very much for watching as always. Apologies by the way if I sound really bunged up in this. I've got a bit of a cold. And yeah, if I haven't said it already, I've been Henry Scott. Thank you very much for watching, and I'll see you in the next one.